In the previous lecture, we used Excel macro to produce 100 results from the random gender reshuffle column, which I copied it in this worksheet here. I also copied the actual risk for female gender in the dataset, which is this number. Also, the overall risk in the whole dataset is this number. So in order to make sense of this 100 results, I produce a number of basic statistics, use pivot table here. I also provided a histogram shown here. I retitle it placebo effect. Notice the average value of this 100 runs is really close to the overall risk in the dataset, which is to be expected. In addition, notice the minimum value is at 34.9%, the maximum at 52.7%. Also, the histogram shows you that the risk based on a gender reshuffle column, which I refer to as a placebo effect, can produce a wide range of results. These results showed us that we can't simply say that gender is a risk factor because 37.2% is a lot lower than 43.5. Because we have seen a randomized gender column can produce cancer risk on the one extreme at 34.9%, which is even lower than 37.2%. On the other extreme at 52.7%, which is a lot higher than the overall risk. So is gender a risk factor or not? Can gender predict risk of cancer or not? So far, it doesn't seem that this placebo effect is getting us closer to answering these questions. Here, I'll need to introduce a statistical way of answering such questions. So instead of giving a definitive yes or no, we are forced to answer it with a sense of likelihood or probability. A familiar example along this line of reasoning is the weather forecast. Instead of saying that it's going to rain or not rain tomorrow, our forecast is tomorrow has 30% chance of raining, for example. It turns out that the placebo effect enables us to provide a similar statement regarding whether gender is a risk factor or not. We now know what the distribution of female cancer risk should look like when gender is not a risk factor, which is represented by this histogram. We can say if gender is not a risk factor, it's more likely to see estimated risk from a data set to be closer to the center than to be on the two tails. To be more specific, we can estimate the probability to see risk between the middle four bins as 25 plus 31 plus 17 plus 13 divided by 100, which is 86%. The probability to see risk in the four bins on the two ends are 4 plus 7 plus 2 plus 1, which is about 14%. We can further say if gender is not a risk factor, the probability to see a risk estimate to be less than, say, 0.3728 is 4 divided by 100, which is about 4%. So similarly, on the other end, we can say the probability of seeing estimated risk to be greater than 0.49 is around 3 divided by 100, 3%. We can similarly attach a probability to see risk less than 37.2%, which is the risk level for female based on the raw data, we just need to find out how many numbers in this column they are smaller or equal to this number. So I can do this by using the formula COUNTIF in Excel. COUNTIF. So in the range, I just need to select the 100 numbers that we produced earlier. And in the criteria, I need to use this format to specify. So quotation mark, less or equal, then followed by a ampersand, followed by this value. So this would tell me among these 100 numbers, how many of them are less than or equal to this particular number. So it turned out to be 4. So this tells us that there are 4 numbers in this column that is less than or equal to the risk from the data set. So if I further divide this number by 100, which is the total number in the column, this would become the concept in statistics that is called percentile. Let me type in percentile. So what this means is the risk level in the data set is sitting at the 4th percentile of the placebo effects represented by these 100 numbers from smallest to largest. In other words, there are 4% of placebo effects that are smaller than equal to 37.2%. I know you probably find this quite confusing already, but I need to give it another push by introducing another concept beyond the concept of percentile. So here, we are counting how many numbers in this 100 results are smaller than this number. But this time I want to count how many of these numbers from the placebo effects are less likely to occur than this number if gender is not a risk factor. So as we discussed earlier, the farther away from the middle, the less likely it will occur if gender is not a risk factor. So now I can create a column that is the absolute distance from the average risk, which is this value, for each one of these 100 results. So let me use this formula, absolute value. This value from the overall average. And I'm going to, again, I will put the dollar sign in front of 3 so I can copy and paste the formula. Again, this new column shows the distance from each individual placebo run from the average of the whole data set. Again, the smaller the number, the smaller the distance, the more likely to happen given gender is not a risk factor. I will also calculate the absolute distance between this number, which is the risk from the data set, from the overall risk. Now I am going to use the same COUNTIF function. I will specify this column now as the range. Now my criteria now is I want to find those results that are less likely than this result, which would be those distances that are larger than this particular distance. So this time I'm going to change it to greater than or equal to, followed by the closing quotation mark, followed by ampersand, then followed by this value. I will again divide this by 100, which is the total numbers. So this value is known as p-value in statistics. Let me use this schematic to further illustrate these two concepts. So the risk equal to 37.2% from the dataset is sitting at 4th percentile of all the placebo effects, lining up from smallest to largest. But if we line up the numbers from least likely to most likely, given gender is not a risk factor, the risk equal to 37.2% from the dataset is now sitting at the 5th percentile. Therefore, it has a p-value of 0.05. So this also means that the larger the p-value, the closer towards this direction, we should be more inclined to say gender is not a risk factor. So what can we do with this p-value? So let's go back to the weather forecast example. So what do you do with 30% chance of raining? I personally will not bring an umbrella with me unless it has more than 50% chance of raining. So mentally, I have a cutoff point to interpret the forecast. If it's over 50%, I consider it as raining tomorrow. So similarly, we need to have some sort of cutoff if we have to have a definitive answer to whether gender is a risk factor or not. Conventionally, in statistics, the cutoff is 0.05, which is also known as level of significance. So if p-value is greater than or equal to 0.05, the cutoff, we would say gender is not a risk factor. So if we follow this convention, our conclusion based on the p-value of 0.05 associated with this 37.2%, our conclusion would be gender is not a risk factor, which is the opposite of our first impression.